Hello and welcome back to Calculus 2 section 10.7 on root and ratio tests. First, we'll talk about factorials. Then we'll talk about ratio test, and then at the end, a root test. Now, this might be a part 2 depending on the time. We have about 30 minutes. This is definitely going to be a part 2. So, factorials. We did not have this talk before. We had it briefly because we can't deal with factorials with any other test than the ratio test. So we didn't have to talk about factorials before. Now, factorials will be in your pool for possible functions, and they will be present for power series in the next chapter, and then differential equations. And special discrete math. So we need to know this. So definition for a factorial, which is this n with the exclamation mark. This is not n, it's n. Factorial, right? Just what it is. Notation. And it stands for 1 times 2 times 3 times 4 times 5 times ... times second to last term n minus 1 times n. So whatever your n is, your job is to multiply all integers up to n, including n. Here's your cloud on that one. So what is 6 factorial? It's 1 times 2 times 3 times 4 times 5 times 6 equals 720. You can also go 6 times 4 times 5, right? You can put them in any order, but I don't care increasing or decreasing, whatever makes you happy, right? Because this is a math course and your happiness is our primary concern. And do you also see right now that this puppy over here is a 5 factorial? Right? So I can write 6 factorial as 5 factorial times 6. Right?
Why? Oh, wait a minute. Oh.
Cool, right? Because 1 times all the way through 5 is a 5 factorial, and then you have times 6. So it's cool. We can also write it as 4 factorial times 5 times 6, right? You can write whatever you want. You just have to peel enough terms. Okay, so that's understood, and the reason why we need that is so we can write and understand the formula that n factorial is n times n minus 1 factorial, right? That's another formula that we want to know. Now, I think that your calculator runs out of memory at either 69 or 70 or 71 factorial. And factorials are under the math symbol. So if you push the math button under second and alpha key, and then you go to PRB, stands for probability, factorial will be on the line 4 for the TI-8384 calculators. And I'm just going to try this real quick.
Yeah, 70 overflows.
70? Okay, 70. So the highest one you can compute is 69, 70 overflows. Yes?
And then you get to 110.
Now, can I still compute 83 factorial divided by 80 factorial?
Yeah, it's going to be 80. Yeah.
Yes. So this is going to be 80 factorial times 81 times 82 times 83 divided by 80 factorial, and then they cancel and you can just compute the rest. So it's not that you can't do anything, right? If there are other factorials around to cancel, I think you learn most of this stuff when you learn probability in your stats class, right? Hi.
The class we have to take.
You know what? It's not bad. How's life for you?
No major issues. You found it?
I did, but it's. What do you mean it's overflow?
Like, it doesn't have enough memory to actually compute it because it's using all zeros and ones.
No, her calculator did it, but this is the TI-89 titanium, and yeah. So
No, it's my brother's.
So
Okay.
so the beefier the calculator, the higher up you can go. Now, for some research, guys, I did 121 factorial. It had 3 pages of numbers. When you have the font at standard 12 and everything standard margins in Microsoft Word, when I cut and paste the number, 3 pages, right? And then I did for the next row of Pascal's triangle, which is 1, 3, 3, 1. Now you can't do this, right? You have to have some special computer stuff done, computer code and so on. I did this in the math software with coding and so on. It returned 27 pages of digits, right, for 1,331 factorials. So these grow very quickly, right? Now, where do they place in on our sluggish scale? Remember the sluggish scale, so we can do the limits to infinity, because we are going to use that a lot here. So let's go with the sluggish scale one more. So growth rate. It's second to fastest. N to the n is going to be the fastest. So we start with the sluggish one, ln. That grows less than n to the p, grows less than ln times n to the p. Oops, should have put n to the p. There we go. Grows slower than the exponential b to the n, grows slower than n factorial, grows slower than n to the n. So that's where it belongs. And then along with this were those sacrilege limit formulas I gave you. Limit n goes to infinity of slow over fast equals 0. And limit fast over slow equals infinity.
What is that third term?
The third term is n to the p.
N to the p times ln n. This one?
Yeah.
Now it looks like a U. Come on.
That looks better.
All right, next.
Oh my god. I couldn't see it before.
Opera glasses.
You understand that you can sit 20 feet closer. You
like,
just choose not to.
I don't like people behind me.
They're not here.
I'm very safe back here.
I only like people
Which means I'm the only one he doesn't like.
Oh.
What was your sentence? He said he only likes people
Oh, we can spin that in so many ways, you have no clue. Time for ratio test. Ratio test. So ratio test is not exclusively for factorials, but all factorials will be done with ratio test, okay? So ratio test does more than factorials. But it is the only test. When you see factorials, you know it's ratio. So that's worth writing down in your notes. And then we'll do the test. So ratio test is the test that you will use when you see factorials. Other things can be done with ratio test as well. All right, cool. So now what is the ratio test? You have some summation an from, let's say, 1 to infinity, 0 to infinity, I don't care. What does it say? It says, if the limit as n goes to infinity of absolute value an plus 1 over an is less than 1, we have convergence. If the limit of an plus 1 over an is larger than 1, we have divergence. And finally, if limit an plus 1 over an is equal to 1, test is inconclusive. I'll just put in use something else. Right? Geometric telescoping, essential oils, like whatever works. So this is your ratio test. These absolute values are not there for decoration. Guys, these absolute values will be killing that -1 to the n completely if you have alternating series with the factorial inside. These absolute values will come back in chapter 11 as something extremely important, and this test is going to be your primary go-to test when we do radius and interval of convergence of power series later on. You have to star this test. This is your probably second most important test on the sheet of paper. Your most important test obviously is the first one, because that one spots divergent series quickly and takes them off your plate in the first 2 minutes of the test. But ratio test is the one that it's used later for chapter 11 and differential equations, and ratio test is the only one that deals with factorials. So that one brings a lot of beef to the table, right? So make sure you know this one. Now you are guaranteed to have this test on your exam 3 and your final. One problem guaranteed to see the ratio test used on exam 3 and final. So there we go. Cool beans. Let's take a look at ratio test. What am I going to do? I want to check something that I know, because why not? How about 1/4 to the n? And before you all scream, convergent by geometric series. I know, right? I wrote the problem. Let's use the ratio test on this, because we can. So your an is 1/4 to the n. Your an plus 1 is 1/4 to the n plus 1. You will set up your limit. N goes to infinity of 1/4 to the n plus 1 divided by the 1/4 no coughing to the n. So now we need to solve this, right? You are going to peel off 1/4 on the top and then cancel the rest. Oh, I forgot the absolute values. Wow. Don't forget absolute values. So we have 1/4 to the n divided by 1/4 to the n. All right, we peeled off one of these, and you can see that these guys go dead right there. And we just have 1/4. 1/4 is less than 1, and we say converges by ratio test. So here is your good old, very well-known problem from before, solved using ratio test, because the limit worked out to be less than 1. If the limit is equal to 1, nothing you can do, right? But When it's less than 1 or more than 1, you will claim convergence for less than 1 and divergence for more than 1. Now let's take a look at summation of n factorial divided by n to 100 minus 7 from 2 to infinity. So what do we do?
Recognize in terms of the ratio stuff.
Ratio test because it is n factorial. Excellent. So the first thing is visual. Do I have negative 1 to the n? Yes, I do. It's alternating. Do I have a factorial? It's ratio, right? So there are these little parts of the problem that will tell you, just like for derivatives, oh, two functions are multiplied. It's a product rule, right? So here, right, n factorial is going to give this. So now I have n factorial divided by n to 100 minus 7, an plus 1 is going to be n plus 1 factorial divided by n plus 1 to the 100 minus 7. So now I have to do the limit. N goes to infinity. And what do I do?
Well, you separate it as n.
What just happened? So limit n goes to infinity, and we have our n plus 1 factorial divided by n plus 1 to the 100 minus 7 divided by what? N factorial by n to 100 minus 7 and absolute values. Good. When we cross multiply, we get n plus 1 factorial divided by n plus 1 to 100 minus 7 times n to 100 minus 7 divided by n factorial. Absolute value.
So you can pull n plus 1 out of the top and make it n factorial.
Yes. So you are peeling off the n plus 1 term.
And then you can cancel out
N factorial times n to 100 minus 7 divided by n plus 1 to 100 minus 7 times n factorial, and this is where n factorial cancels. So now what do I have? I have technically n to 101 divided by n to 100. What do I know about that? E equals infinity, exactly. So E equals infinity because the top is bigger, and we immediately claim divergence. That's bigger than 1 for sure. Divergence by ratio test. Your job is to be able to take the limit. There's nothing else we need to talk about. Let's see what else we can find for this one. I'm gonna pull something from the book. I have like a whole bunch of these cool problems. Ooh, I believe this one was on one of my exams like 2 years ago or something like that. 2 to the k divided by n to 99. So you know the drill. Get your no k, n. Either all n's or all k's. I don't care. All n's or all k's. The book, I don't know why this book has k's. Like every other book has n's, and this one is like Watch you find one book over there that has like M's everywhere. So this is another one of those quick problems, and then the next one we're gonna open the gates of hell. We have our an to be 2 to the n over n to 99, and then an plus 1 is 2 to the n plus 1 over n plus 1 to the 99. So we set this up as the limit, really. Limit n goes to infinity, and I have absolute value of, and now look what I'm going to do. I'm going to like do 2 steps at once.
To the n times 2.
I'm going to peel off 2, and we have times 2 to the n, right? Because that plus 1 peels off, divided by nothing I can do here, and then times the flip of the original problem immediately. So I don't have to write it 15,000 times. So it should be this divided by that. So that one you just peel off what you need, write it, and then flip of the second one, instead of dividing, multiply by the flip. And what you have is that these guys cancel, and you have limit to be what? 2.
I'm sorry, what?
Limit is 2.
Or you just cancel it as infinity over infinity.
Because, yeah, if you take 99 derivatives, right? The only thing that will survive is the 2 in front. When the polynomial powers are the same, it's just front coefficients. Well, there's a 2 over there. That looks almost like a clown. We can finish this off. So, larger than 1 diverges by ratio test. Now, those of you that have attention to detail, you would say, yeah, I have the faster growing functions upstairs. It's exponential divided by polynomial. I don't care what numbers you put up. Eventually, exponential is going to win. So, yeah. Lock the doors. Summation 1 to infinity of n factorial squared divided by 2n factorial. I'll let you bake. Now, this is mathematical flexing. I mean, nothing works this way. But let's see. Yes. Like, look, that's what this problem is.
Yeah, and I couldn't do that either.
Which is why I have all the teeth today.
There.
Your n gets increased by 1. n, only n, not expressions, just n.
Would this be the right way to separate it?
Yes, each one gets their own square.
Okay, so then it's just inconclusive because it's n plus 1.
I don't know. It should. It shouldn't be inconclusive. Let's see.
Or divergent at least.
Or divergence at least. I would make the argument for divergence because you have factorial squared divided by the straight factorial.
Yeah, it's n plus 1 at the end, so it should just be infinite. Never mind, not 1.
N plus, oh, okay.
Yeah, so it's n plus 1.
So we have our an, which is n factorial squared divided by 2n factorial, and our an plus 1, which replaces, now let's do an plus 1, which replaces hn by n plus 1 factorial, everything squared, divided by 2 in parentheses n plus 1, oops, no square. Now close this one and the factorial. Alright, cool. So now we're just going to work out algebra. N plus 1 will be peeled off, and then we still have n factorial divided by, and now I have to over here go 2n plus 2 factorial. Oh, I forgot to square over here. Oops, there we go. So now I will have the n plus 1 squared and n factorial squared, because the square applies to each one of the factors inside the parenthesis. And good one. And in the denominator, I need to go back to 2n. So I have to peel off 2n plus 2. I have to peel off 2n plus 1. And I have to peel, and then I have my 2n factorial. Right?
How'd you get a 2n plus 1 on the bottom?
That's what I'm, because 2n plus 2, so the previous term is when you take away 1, right?
Because it's 2n plus 2, yeah, so it's n plus 1 times 2.
So this is
Oh, okay, got it.
this is my an plus 1, I hope. Let's see. So limit n goes to infinity. I have this n plus 1 squared n factorial squared divided by 2n plus 2, 2n plus 1, 2n factorial times the flip of original an, which is 2n factorial on top divided by n factorial squared on the bottom. So now that will cancel this one and this one and this one and this one, and we are left with 1/4, which is less than 1, so should be convergent by ratio test.
I just didn't do
I am going to check this one because to me it seems that it should diverge.
No, because
I calculated convergence.
yeah.
I don't like the answer. I'm gonna check it in Mathematica, and then if it turns out to be divergent, we'll have to figure out again what happens. So let me just type this really quickly.
How are you multiplying by 2n factorial and n factorial squared?
What do you mean, how do I multiply?
That's dividing by the original one.
Yeah, are you talking about
yeah,
this?
yeah.
I skipped the step where I wrote them as a division. I just wrote it as a flipped multiplication. Okay, sum of, and what is our problem? It's open parenthesis n squared divided by 2n factorial. I love Mathematica. Do you know that this actually adds to 2 over 27 times 18 plus pi root 3?
Yeah.
It's obvious. It's clear.
Whenever I check all my quiz answers
Especially
on
when we can
the
get high
integration
root,
calculator, it just gives you this weird ass flex where it's just like, oh, it's 8 times x to the x to the x over like 17. It's like, yeah, I can take the time to add that up, but that's not a concise answer. Why do you think that's simplified? You
Yeah,
made
so-
it more difficult.
Oh, I think I understand. Because
I
like,
don't know why that's
for you to get whatever you had squared, you would just be multiplying by the same number again. And for factorial, you're multiplying by the next number. So the difference is only like one factor of that beta number. But on the bottom, you're multiplying by 2. So you're already multiplying by like an additional number that's included in the end. So if you're raising n factorial to an exponent, it doesn't change because it grows so much faster than n to a power.
Yeah, as a polynomial. Okay, I see it.
No, but, like, yeah, no, the answer makes sense looking at it like how you did. I just realized that I didn't break up the 2n plus 2 problem.
That's why I said this is not an easy problem because you don't have enough experience with factorials, right? So hopefully you will find more factorial problems and work that. So I'm going to open the homework. Now the only test we did not cover is the root test because the class ended 3 minutes ago. Now, next class we are going to finish the root test and we are going to do the last section of chapter 10, which is the way you pick the tests. Remember how we had a survey for section for integration and say if the integral, we had them. We're going to do the same thing next class for series. The most important problems for you guys is when they go and they say choose your test and they just dump 60 problems on a pile. So choose your test and then you open your textbook. So the next class we are going to take a look at at this mess here and say, okay, what are the tests? And that's how. So some tests on your exam will say, some problems on your exam will say, use geometric series or use integral test, right? But some of them will just say, check for convergence. Right? Then you need to know. So I would say maybe, 2 or 3 will tell you exactly what to use, and then the rest you guys will have to know what is out there and what they look like. So our job will be to say, oh, factorial, that's immediately, right? Ratio test. So you can spot where is the -1 to the blah blah.
Yeah, whenever I'm watching TV and
I don't see any.
I'm wondering if I'm watching.
You get the
Oh my
idea.
God, I'm so sorry.
No, that was me. I forgot my jacket.
Yeah, I just got it. Yeah.
So
It's like a ratio.
we'll have the part 2 of this next class.